So, like what Andre was saying earlier is that like blockchain's a like one size fits all solution, and in Holochain we have a a one size fits all solution doesn't fit all. So for Holochain we have a fit for purpose solution, right? Andre's probably better equipped to communicate about the Sybil attacks than me, but I can touch on a couple pieces about security on Holochain. Is that if we high five, right? Do you care if everyone remembers that? Oh, that was awesome. All right, let's high five. Do you care if everyone, do you want everyone to remember that first high five that sucked? I don't. Okay, whatever. So we don't need any security for that high five, right? Like I don't need a huge amount of security for that high five. I want to text my girlfriend a heart emoji, right? I don't need a high amount of security, but if I want to like approve of that text, but if I want to approve of a nuclear missile getting sent out and it's still a sending action, right? I want a much higher level of security. So on a Holochain app, you set the parameters for security for the needs of that application. The same way as you set the parameters for the storage or for the backing up, right? So I might need to know, like if I'm going to have an interaction with you and I'm going to sell you a house, we're going to want a ton of people making sure that my identity that I'm representing in that purchase and your identity and your assets and my assets are valid. But what we're going to need for the instance of a house is going to be different from the instance of a high five or a heart emoji or a nuclear missile. You want to explain Sybil attacks?
On the Sybil side, again, Holo allows you to have a fully configurable system. So you could, because Holochain just powers the app itself. So nothing stops you from implementing your own proof of stake system in that to convert Sybil, or you can have a proof of work entry mechanism to stop it. I mean, you'll have a very specific defense for a specific attack vector you expect in your solution, but it's not generalized to all of them because not all of them need it. So the tools to facilitate a defense, if you expect yourself to be susceptible to that, you can build within the architecture. So in the example of the house, there you have a bunch of participants, so you don't necessarily then want to be able to get a Sybil attack there by someone. He decides he's going to throw 51% of the participants and then obviously claim it. So, okay, never mind.
So you don't need to do proof of work, period, right? So because we have, and you can correct me if I'm wrong, because we have a distributed hash table, right? So like, let's say we're all on one app right now, and when it's on the Evan and Bear house buying app. That's the name of the app. You can find it on Google Play right now. Thanks, Evan. That we're on this app. We're all on this app, and that we require 20 people to let's say everyone in New York is on this app. It's a very popular app. When we're pulling to validate that interaction and to prove that we are who we are, we're pulling at random. You can't actually control who's on the network unless if you have a network of 5 people, yeah, you can have all bad actors. But if, let's say you have all of New York City and you've got like 40,000 people in New York City on like helping you, you're still not going to be able to do it. And if anyone is putting information out that's saying that what that's validating your change of state, because you have a local state and I have a local state, you changed your local state to lie about how much money you have, I'm going to pull from that network. And if one thing from that network shows up and says it doesn't match, that's going to be a buzzer to me to check into it more. So that's how we do it, I think. I know you don't need to do proof of work to avoid Sybil attacks.
Must the Holochain applications run on Holo, or can they run on any cloud infrastructure?
So if you want your Holochain application to be accessible to anyone on a web browser, you use Holo to do that, to do that serving. But you can also create your own network and serve it from your own network, theoretically. I think that's actually what hum.earth is doing right now. And they have a Holochain application that's live and Holo is not, right? But effectively, easily, and scalably, if you want to serve something to the world, Holo is what you do that with. But you can run your own Holo. Hell no. No. Holochain is a framework. You can, yeah, okay. I get loud because I get excited.
I think this question's for Andre specifically. I think you had it in your slide on how you're, like in a smart contract world, how you're preventing us from having to execute the same smart contract on every single block to validate that, that piece of code actually ran. And I think there's something around the whole zero knowledge proof or something. But I'm really curious, like how the hell that works. Like, how do I know that it was that contract that generated those transactions and not an imposter contract?
Yeah. So what you do is a traditional VM just encapsulates the VM itself. So you wrap now that VM execution is just a set of circuits, and these are standard arithmetic circuits, logic AND gate or OR gate or whatever you might have in there. Now what zero knowledge proof, specifically snarks and starks, allow you to do is they allow you to codify these circuits in a set of rule that then map out the sequence. So what zero knowledge proofs do is they sample, and this is not a technical explanation, I'm trying to bring it a little bit down. They sample one of these circuit areas to see what was the result of the answer at that point in time for the execution, and then test that against what they expect the full execution to be. And that allows them to generate a proof system. So the arithmetic itself of the logic gates is what creates the proof system that at any given point of time that can't be known by the generator or the attacker is generated to prove that it did reach that logic gate successfully. So by doing that, the output that you have that gets generated along with the execution is the proof. You can bring it back to standard public-private key signing, in that by signing this message and giving you the public key and the message, you know that I'm the owner of that private key. It's a similar concept, but with code execution. So by having the output, having the proof at the given point of the logic gates, and having the inputs, I can, with just these 3 bits of information, test it like a private public key pair and know that the execution, as if the execution is the private key, occurred to sign the output of the message. And then I can just apply the state differential there. So you would output a standard Merkle tree, for argument's sake, and then apply that to your own state system. So in complex logic, it's faster. But for example, if you did something very basic like 1 + 1, it's actually more effort to test the proof than it is to test the execution. But in complex execution, it's a lot faster to test the proof than to actually do the execution.
And you're validating that the code executed did what it did? Can you also validate it that it didn't do something you didn't want it to do?
So technically, you can only test that it does what it's supposed to do.
So you can test the fact that the outputs are correct based on the inputs. But if I've got I can't prevent somebody who, say, maybe creating a secret log inside that contract, like it wouldn't necessarily validate that, right?
So when the circuit is compiled, it's compiled off of the binaries themselves.
Right.
So you won't really be able to inject that, because any change in the bytecode output affects the circuit output.
Okay.
So, but let's say you had it one level removed where you weren't running it on the bytecode, but you were actually running it on this execution and not testing the bytecode, then potentially you can do something like that. But because it's part of the precompiled binaries of the bytecode, no, you won't be able to inject that.
So you basically do get some validation that this piece of code, when it ran, really did come from this GitHub repo, it was this version of the contract.
So it's that signed binary that's available and that runs, and you can always test that against the original execution as well.
So it's validating not only what you wanted it to do, but you also get some validation that it's not doing something else that you don't want it to do.
Yeah. So that's actually where, verified computing is the one part, which is specifically the output of the circuit. But the other side is the formal verification that I mentioned earlier. Now the formal because when you see GitHub code, you still don't necessarily know that code is the binary you're running. So the verified computing is the binary that runs and proves that those inputs created those output. The verified computing is the thing that actually says this source code based on this hash created this binary, and here is a certificate certifying that it is the output thereof.
Yeah, that I can get the understanding of how you could do that. You could generate a trust chain from the source to the compiler to the binary.
Oh, you shouldn't.
Well, yeah, I mean, I know, yeah, in general you don't, but I can see how you could build that. You could build a signature.
So one flaw of this is that because you have to use you don't have the full elliptic curve math at your disposal. So your circuits are a little bit limited. So you don't have full Turing complete systems technically. You can build it with the correct amount of logic in it, but it's more effort for the user. So it is a very specific kind of execution contract you're talking about. But it's perfect for standard financial contracts and these kinds of things. It's not really that good for super complex contracts because you have to use pairing-based cryptography instead of elliptic curve-based cryptography. But that's really the only shortcoming thereof at the end of the day. And then you've got a proof system for execution. So it's not actually just that we're using. There's actually a secondary mechanism, because now each of the nodes still have to validate that proof output, and that's still a lot of overhead. So that same knowledge graph concept we have in our consensus, where the one tells the other one that it told the other one, which creates that graph, we actually do the same with the proof system as well. So if there's 3 nodes, the first one tested the proof, the second one tested the proof, and the third one knows that the second and the first one tested the proof, then it doesn't test the proof, it just applies the state, which also cuts that overhead a little bit more. But that's actually a secondary system to the knowledge proof. But there's a lot of really exciting stuff happening in the zero knowledge space. Bullet proofs are great for long range attacks. Snarks are fantastic, and we are using them. The problem with snarks is they require trusted setup, which currently obviously isn't great in the distributed environment. And the research happening on Starks right now is with a completely trusted setup, and it's linear testing on code execution, so it's not as fast as snarks, but it's better for a decentralized world. So if you're interested in the space, definitely go check out those 3. They're the 3 front runners for this technology. Awesome question, by the way.
We're just gonna take one quick question from. So Simone is gonna.
Hi. Okay, I'm Simone. I'm part of the Fantom community, and I have some questions from the Telegram group. So, it's not the bias. Okay, so one is Fantom looking into the possibility of building a DEX?
Yes.
Yes. Okay, the other one is they want to know more information about staking and hardware requirements for staking.
Okay, so staking I can't comment much on. Hardware requirements is a function of the binary, so that I can talk about a little bit. So staking actually has a little bit of 2 models in that number 1 is we have this algorithm to be able to use memory and CPU testing to be able to ascertain the capabilities of a given machine. So we know the specifications by doing limit threshold tests. The more processing power you give to the network, the bigger your stake differential is. So the more reward you get for the hardware you're contributing. But at the same time, it's a proof of stake solution. It needs fast connectivity more so than anything else. And the consensus solution, because it's decoupled from the VM, doesn't actually do storage. So it itself is a few kilobytes that can run on a mobile device. So there aren't any hardware requirements, and you can still participate in the network because you do add security then. But you will be better rewarded for providing better hardware.
I have one more, and this is, yeah, I know, sorry. I mean, there's supposed to be Holochain guys in here too, but they're asking a question about Fantom. The last one is, and I know you're gonna hate this because it's about TPS. Okay, so if you think that the TPS numbers from the testnet stress tests will be achievable on the mainnet, and is it even relevant, and what's your old thought about TPS? I added this last part.
Okay, so number 1, do I think the current threshold tests in the testnet will carry over to the mainnet? Both yes and no. Assuming it is a good network participation and that each node is bringing transactions into the network, the transactional throughput will increase. It'll be more than we have now. If you have only 1 node originating and you have 10,000 other nodes that are sitting in disparate locations with bad connectivity, then it's going to be significantly slower than it is now. So the accurate answer to that question is it really depends on each node's contribution. The more, if I can call them leechers you have in the network, the slower it's going to be. The more contributors you have, the faster it's going to be. It's a network effect system. So the more contribution, the more value. What do I think of TPS as a general metric? I mean, let's face it, there's no standardized tests, there's no standardized implementation, so it's a garbage metric. I mean, one chain's TPS is 1 byte per second, and they transfer that between 5 nodes. Another's is a gigabyte big, and they transfer that over 24 hours with a terabit network. It is a complete garbage metric that you can't compare from one blockchain to the next unless there is standardized testing, which currently does not exist. Yeah. I mean, you could eventually design a standardized test. IBM Hyperledger is actually doing a project like that. That's actually quite nice. But you have to build towards their protocol for the test to work. So right now it's all like EVM throughput based. And if you're not EVM throughput based, well, you can't use the tests. Sorry. So the stuff like that.
Two questions for Eric. So are you still on track for mainnet release this year? What can we look forward to from a product roadmap perspective? And number two,
product what?
roadmap perspective. And then number two, can you help explain the value proposition behind HOT post swap? So basically the native token in the future.
Okay. Yes, we're on track for having OpenNet exist this year. Woo! And I mean, we're working on it. It's coming together. It's challenging. Rust has been challenging. It's also challenging for user adoption, but we're excited to use that language because it's so strongly typed that it'll allow us to create the security that we need in order for Holo to work and for Holo Fuel to work, which leads me into Holo Fuel. I don't know if we've already started shipping, but we're going to be shipping out actually for the first person, shipping out the Holo ports. We've started shipping out the Holo ports already. So like there's actually like physical things in the world that now exist so that you can run it, which is cool. And as far as the hot Holo Fuel relationship is that what we're set up to do is you'd be able to swap back and forth hot to Holo Fuel and Holo Fuel back to hot. Originally, it was going to be you destroyed your hot when you turned it into Holo Fuel, but we've shifted it so that now you can go back and forth, and that Holo Fuel is going to be the currency. I got to burp, but I'm not burping it. That to pay for hosting on Holo's network. And just to be clear on how that works is that whatever business model a business has stays the same, right? For serving its web app to people online. Maybe it's a membership model, whatever, right? And that they pay that money goes to whoever owns that app. And then that app is being hosted by people who have server boxes who are running Holochain and Holo. And then Holo connects them to the person who's using their web app, right? So then that's the relationship. Okay. And then the owner who's making the revenue from the membership fees, it's more fun when I draw this with pictures, that they're paying from their revenue for the hosting the same way they would if they were doing it not as a dApp. And then Holo takes 1% or less of a fee for the transaction for the hosting. So 99 or more % of what gets paid actually goes to someone who is providing that hosting at home, and the payment is in Holo Fuel. Yeah, that's how that works. And that's also what we're aiming and what we're like banking on being an actual land shift is that the currency is so intricately tied to a usable asset that it will ultimately stabilize enough to create an actual stable market. Yeah.
Any others?
I just had a quick question for Andre. What will be the implications of quantum computing on the security of blockchains or DAGs? Where is the thesis coming from? Is there academic research on this?
Yeah, quite a bit actually. I released an article a while back that goes a little bit more into like which hashes are susceptible and where the dangers lie in. So there's a little bit of a current implementation of quantum computing, and then there's sort of the theoretical max implementation of quantum computing. So what everyone's afraid of is this maximum method of quantum computing, which can basically guess a private key for a public key instantaneously. But people always equate it to quantum computing. You give it a maze, and a traditional computer has to run multiple laps to try and get the answer. A quantum computer can just map all of them at the same time because it can switch all of the different possibility of bits and then arrive at the answer immediately. That is a much bigger risk to general EDCSA and all of the standard cryptography that goes with it, if that ever happens, which we technically don't have the physical implementation to support that, so we can't build that version yet. There are a lot of, not a lot, there's a subset of cryptography that specializes in specific hashes that aren't susceptible to brute force attacks or guessing like that. They do exist, so a lot of the different chains are moving over to that. The more current implementation is just a much faster brute forcing method. So it's not the super version, but it's still faster than general computing now. And while it's still at risk, even the quantum computers we have today to guess a standard private public key in EDCSA is going to take it at least 100+ years. So we're still not at that immediate risk problem with the solution. And by then, a lot of the standard cryptography can switch over to more secure hash systems. Pleasure.
Just a shout out to Andrew. I really love your code reviews. So thank you so much for doing that.
Awesome.
Like, most of that just goes over my head, but thanks to you and John and everybody at Crypto Briefing for actually doing that. So
awesome,
fantastic job. Yeah.
Awesome.
Yeah. And where's my Holo port, Eric? So thank.
It's been challenging.
Right.
Coming
Yeah.
out of China, and then they ended up getting check-this computers, which slowed the process down more. We tried explaining, no, they're not really computers, but they're like, we're not into your complex stuff.
Yeah. So I ordered a bunch of them when you guys started your. Perfect. Thank you.
I'll ask my other questions. For the block, this is for you, Andre, for the block propagation graph and everything like that, for the block size versus like time. For your example that you're giving, let's say like someone wants to order like a quantity of like 2 or 12 or 24, how will that impact like the block size and the time, like the efficiency to be able to like show that there is proof and everything like that? Would that impact anything by quantity?
Okay. Can you just rephrase for me? I'm not following the question.
So for your example, you're kind of showing like just one checkout for one person. If there's like one person with multiple quantities of things, would that impact like the block size or like the time it would take?
So again, this is a lot about the originating entity. So if all of them are originating at the same entity, yes, it would impact it. I mean, the loads are still small enough that a single node proposing a single block could fit all of them in. But let's, for argument's sake, say this thing has reached a trillion purchases per second. If it all has to go through one node, eventually it would reach the size cap. That is the distribution between the network, and that will start causing latency issues. But in that case, instead of using one node, you'll simply split it between a few nodes so that you leverage each one. And then you end up leveraging the combined throughput. But yeah, if you use a single node, you're gonna eventually have a backlog cap.
Okay, so like also like on the graph and everything like that, after a certain point, it was like becoming more uncertain. So do you guys like work within like certain like operational thresholds? And then do you have to like kind of configure how you do block size over time to kind of equate for those uncertainties?
So what we're actually trying to do, this isn't currently part of the protocol, but the research we're busy with is building a network graph overlay, so that via standard transmission times, because we have this knowledge about knowledge graph that we're building, so we can use that to kind of detect how far a node is away from a given node or how close it is. And then based on that, if the network starts becoming bad, instead of adjusting the network itself, we actually have a network pruning mechanism that starts looking at these bad nodes and starts removing them out of the network to keep the node in an optimum condition for the configuration, instead of changing the configuration to adapt to a potentially bad network. So it's the secondary pruning layer that we're currently playing with. It's not fully implemented because it's currently very centralized, which we don't like. So there is still a sort of ungoverned, there's a governance adaptation layer, but that's voting based, not system based. So it could change the sizes, but then it's based on community votes. So it's not technically the same. So the second validator or observer layer is technically the best way to keep the network in an optimum space.
A quick question again. I know Matt is very tight-lipped when it comes to any enterprises or any collaborations on the AMAs, but any updates on any collaborations like Mozilla or any other things that you guys have been working on?
So we've got a number. We're not tight-lipped on a bunch of the projects that we're in partnership that are building on Holochain, like Junto, RedGrid, Next Legal. We've got a few dev shops. There's like a handful. There's like a number of things that are in different stages. Just One Organics, Producers Market, Hum.Earth. There's some really cool projects getting put together. We're doing more work to actually share about them more and more. We've got more things coming out on Telegram, more spotlights, that kind of stuff. Yeah, there's no new news around like, Mozilla partnership or anything like that there. Yeah, we're in discussion with a small number of enterprises at the moment for stuff. Yeah, that I'm also going to be tight-lipped about. Yeah.
This is what I meant by tight-lipped. So.
Yeah.
Thank you.
Yeah.
For an entrepreneur, what are some of the key differences between IOTA and Holochain?
Like, I guess it depends on the use cases that you want to do. I think that IOTA and Holochain has distinct use cases, but I mean, who knows?
Such as
IoT is focused. IOTA is focused on like IoT. It's a lot of like P2P and working with like machines and devices. So it's kind of like a couple layers from the like the actual user itself. While I believe that Holochain at least is working on applications that directly impacts the as the human user.
So, and I'm not part of the answer, but just to kind of give it the thing about all of these layer 1/infrastructure chains is that's like, what's the difference between the different operating system? What's the difference between different phones? What's the difference between different databases? They all facilitate the same purpose. Most of them look the same, function the same, act the same, but their niche in terms of their market development or their business development or their community development is normally a very specific vertical that's focused on a very specific domain area. So I mean, IOTA has this great transactional processing capability, which means the more devices that come into the network, the faster its throughput goes. So it's designed to have billions of IoT devices connected to it, and its niche is in that area and getting that information, not necessarily keeping it forever, but just processing it as fast as possible. Versus on the Holochain side, it's a lot more about these extra communities and all of this extra stuff you can build with it. I mean, if everyone in this room wanted our shared social network, then we built that and we use that without needing to affect other systems. So one way I like to describe it, if you look at something like Ethereum, there's 900 different ERC20 tokens. Now, if one of them gets a lot of transactional volume, it affects all of the ERC20 tokens. If they were all designed on Holochain, then that one would get busy, but it wouldn't affect the rest. So that's a fantastic solution for these distributed consensus isolated products. And they're focusing specifically on the Holo product side, on the new decentralized web, which is focused around new standard of web hosting, a new way to present websites and interact with them, etc. So definitely their niche, but if you strip all of that stuff away, all of the SDKs and the APIs and all of that fluff, and you just look at the protocol layers, then it's, what's the difference between Apple and Microsoft, or on the phone side, Apple and Samsung?
I just want to add one piece to it, which is, and thank you, that we do work well with IoT devices. Actually, one of the projects that I mentioned earlier is called RedGrid, which is a electricity sharing ecosystem, basically, that's getting built by this organization in Australia. It's pretty rad. And, you can have a bunch of little smart meters connected to each little patch of solar cells saying that this is how much they're producing. And then each of those IoT devices functions as its own agent on the network. And you might even have little sensors in places that don't have the brain to do it, but they can take sensor data. And all you need to do is put like a Raspberry Pi, or even something a little dumber than that, because Raspberry Pi is more than you need to run. We ran like 20 something nodes on a Raspberry Pi, right? To run a node, and just have that hooked up somewhere so that it's talking and then it functions as a user.
And then a follow-up in terms of other DAGs in the industry that are getting traction.
Other DAG-based solution that are getting traction. Avalanche is getting a lot of traction. They're a DAG-based solution. So again, DAG-based solution is difficult because you've got transaction-based DAG like the Tangle with IOTA. You've got consensus-based DAG like Fantom. You've got what's the other top 10 one? I always forget about. Nano, which is a block latest type DAG. So DAG as a nomenclature is common a little bit misused because the structure itself is used in very different ways in all of these projects. But the ones implementing some kind of DAG structure that are getting a lot of traction, I mean, IOTA, Holo, Nano, Perlin, Avalanche, Hashgraph. I wasn't that impressed with their code. But yes, Dispatch Labs as well, technically, but they're the same organization. Anyone else? What else is there? That's about the ones I can think of. No, I don't know them. But okay, so there's a few. I mean, it's and as the attention and the technology is developing, there's going to be more, and hopefully better ones.
I'll ask one more question.
You guys can leave whenever you want.
So do you foresee a sort of marketing craze that sort of kind of happened with sort of like the EOS and Ethereum battle?
From my personal perspective, I hope not, because there was so much noise and there was so much garbage going on that it was incredibly difficult to actually focus on the pure tech. Like I was reading so many absolute nonsense white papers to try and get to the one good one out of the 200 that are ICOing, versus now all of a sudden you only see the real like diamonds on the tech side that come out. So obviously from an investor or speculator side, that's a horrible thing to say, but from a technology side, the lack of hype is one of the best things that has happened. I think that's it. Oh wait, no, one over there.
I want to check in. Where's Dan? Dan?
No, we lost Dan.
Okay. All right. Cool. We're gonna take it. Keep going.
Teamwork.
So you briefly mentioned that tokens on IDEXs are on DEXs are custodial backed, or like some type of tethered asset, correct? Is that necessarily true though for ERC20 tokens?
No, ERC20s are 100% controlled by Ethereum, and you own them 100%. So
Okay.
They are a true example of full custody. But the problem is that means that everything always has to live on Ethereum. Eventually, you'll want to trade stuff that's on EOS with Ethereum, with stuff that's on Bitcoin, with stuff that's on whatever other network you want to add into the equation. So that's why I meant true decentralization protocol, in that for it to be a true decentralized protocol, there has to be a cross-chain custodian mechanism that's not centrally controlled or managed. I mean, if you look at some of the base cross-chain guys, like right now, I think Wanchain's probably one of the implemented forerunners. But I mean, their Stormen are a semi-centralized method to get mapped assets onto their chain. So there's not yet this true decentralized mechanism. But blockchains are fantastic at controlling everything that's on the blockchain. So yeah, if you could get all of the assets just onto Ethereum, then Ethereum could be the platform for the one and only DEX. But we're going to see more and more chains come out with more and more assets.
Yeah, so if like Fantom's going to launch their own DEX, but it's a ERC20 token, how will that play out?
So the DEX specifically with Fantom that we're investigation isn't just us. So we're using the decentralized custodianship from Fusion, because they have that technology, just on the DCRM side. So that's a distributed key that can control via your account another account on another network. So how that works is my Fusion account can control my Bitcoin account via a decentralized key that's controlled by the Fantom network. So then instead of interacting with a map asset, you're actually controlling the downstream asset. And then the consensus side is what gives it the speed so that we can actually do the order book matching and the exchange matching. So it's a combination attempt.
Okay. All right, cool. Thank you.
We've got 3. We're going to have to take a stack in a minute. I want to just check in with you as well. Yeah, sure. How's everyone feeling? You're getting bored? Do you want to keep going? Yeah. Okay, we'll keep going. A couple more questions.
Keep the flow.
Hi.
Just gotta check.
I have a question about I like the whole idea of the market cap bringing us back to the gold standard with a set limit. But if it's just I'll take the example with Bitcoin and the hard fork that birthed Bitcoin Cash, and then we saw Bitcoin Cash hard fork. how do we stop hyperinflation if we're just going to hard fork every time the demand or a massive upgrade needs to be made?
So to me, that's more, again, on the speculator side, because I mean, the Bitcoin cash fork and the Bitcoin SV and whatever else has come from that thing should never have happened. They didn't add to the ecosystem. They didn't improve to the ecosystem. And it was garbage cash grabs of people that just saw an opportunity and then went for it.
But they all three still exist.
And that to me is like Bitcoin Gold is still like top 50 or something. To me, that's insane. Like the team have literally admitted they are not working on it anymore and have abandoned the project. And yet...
Well, we have the Lightning Network now, so there's no point. They're obsolete.
I have a lot of other comments on the Lightning Network.
To hear about that.
But it's a problem, but I think it's more of a speculator problem.
Oh, just one more, if you don't mind. Where do you see the future of privacy coins and regulation? Do you think that government will just do away with them entirely because they can't be?
So any regulated coin will probably not be allowed to be private, but there will always be room for private coins.
So no more XMR?
From a regulation side, no, and they won't be accepted as regulatory coins. So you'll have this regulatory asset class of coins that will be accepted, and you'll have the borderline ones that won't ever be accepted, but that won't mean they won't be used. They'll just, again, have their niche.
I have something on that. Right. So if you've been looking at like the Mimblewimble protocol and looking at like Beam and Grin and some of these like next generation privacy enabled projects, there's a distinction between being anonymous and being private. So there are a lot of projects like Zcash, right? They're talking about partial disclosure. So they're actually working pretty closely with the regulators and with these banks to say, hey, we've got this privacy enabling technology that will allow us to have components of our network be private. But then we can expose them, you know, based on regulation and based on kind of regulatory scrutiny. So I do think that they're like, I think private protocols will be regulated in, but I think there's, to your point, I think there's always going to be like something more private and something more devious that like will kind of be in the outskirts, like Grin. Maybe not Grin.
I think that we've seen like the birth of a lot of stable coins recently. How do you see that playing out? Will there just be one?
Oh my God, I can answer that too. Wait, do you want to answer that? Stablecoin? So there's lots of different, I just did a report on this. So there are different types of stablecoins, right? There's there's like fiat-backed stablecoins, so Tether. There's also like crypto-backed stablecoins or crypto asset-backed stablecoins, and there's some that are regulated by like algorithms. So like Basis was gonna be like an algorithm-specific or like a tuned stablecoin. I don't know about you. I think that Maker is going to really win the day just because it's like decentralized, not because it's on Ethereum, but because it's this mechanism to kind of be pegged to something, but not be centralized. Because at the end of the day, when you look at these stable coins, it's kind of like you're giving up one devil for the other. Not saying like traditional financial institutions are devils, but like it's this idea if you don't trust them for X, Y, and Z, why would you trust like someone's just printing out their own money? I don't know. But I do think that they're going to play, but I think that the ones that you can like speculate on them, I think are going to probably have more interest. So yeah, right. So like Basis is one, they've got DAI, and then they've got Maker, which you can then collateralize the Maker tool. But then you've got like Radix. Does anyone know Radix? Yeah, Radix is funky, right? They're creating this like economic model where if you create more, so it's a stable backed asset, but it's backed by like their own algorithm, and it fluctuates based on supply and demand. But what's supposedly, they might have changed this, but what's really interesting is that if you're holding more of the, like if you're holding the asset and more is created in the system, you'll actually get some of that that's created. But if some is destroyed, you don't lose any. So there is kind of this interesting dynamic where you're getting value by participating in the stablecoin network, but you're not really speculating on it. I don't know. I feel like the stablecoins are just like, I don't know, stable. Yeah, they're here to stay, but I think that there's definitely gonna be certain ones that are gonna win out. I don't think it's gonna be like the fiat-backed ones.
I mean, I just had one quick follow-up question when you were talking about true decentralization. And if I can understand it right, you're talking about like completely different blockchains where I may need to like either like be able to swap like two fungible tokens between two different blockchains, and or another thing that I was wrestling with is this idea of like non-fungible assets, which have to be synchronized across different blockchains. Like this is sort of what you're talking about in these emerging, truly decentralized algorithms.
Yeah, look, I think there's a real solution, and then there's kind of the current stopgap solution. Now, the current stopgap solution is just being allowed to have a layer above that allows you to talk and control all of the different chains. So an argument here, this is like, let's say you built your own network a few decades back, and you invented a new communication protocol and you called it TDP for argument's sake. Now, eventually UDP and TCP comes along, and now you don't redesign your whole network, but you put a layer on top of that to allow the people above to interact with TCP or UDP and then to interact with your network. So that's kind of where we should get, but that needs specifications, that needs buy-in, that needs a consortium, kind of like W3C or anything else that we have, and that's still a little bit away. In the short term, because all chains sort of at least adhere to similar cryptography, so one sort of standard we have across them is ECDSA, and there's a few others we can add in as well. So by having distributed ECDSA, at least, it means that I can have single control over multiple chains and actions. So doing this allows a if this then that scenario. So I can say, if 10 BTC arrives in my Bitcoin wallet, then trigger this Ethereum smart contract to issue these to the Aeon network, for argument's sake, because all of them use ECDSA. So this one rule that I set can control it in all of the different chains. So that's sort of the start, but that's not where it's supposed to be. It's supposed to be at a point where there's actually a protocol of communication between the chains. But getting that's going to be a lot of hard work, because right now we still have this philosophy. Well, most of the companies have this philosophy of there will be one chain to rule them all, which is just bullshit, because I mean it wasn't true for any industry in our world, so it's not going to be true for this one. But they're still functioning on that principle. So interconnectivity and communication is still sparse at best. So we're kind of starting with the one commonality, which is at least the cryptography side, but it should actually be on a protocol layer, something like the actual P2P communication or RPC worst case scenario, and not the cryptography side.
And you can sort of create sort of almost like a meta super contract that is executing things across two, make sure that something is executed on one blockchain and executed on the other, and validated that they both occur, and then come back and say, okay, everybody's good.
So that's the current implementation, but that's not how it should be. These chains should actually be able to interact with that. So when that happens on Bitcoin, it should have a protocol that allows it to interact with Ethereum to be able to do the next step instead of this thing on top. So right now we're doing it with this thing on top, but I want to
custodial thing. It's effectively you have to both private keys and both sides to do something.
But the chain itself does it in a completely distributed and decentralized manner. So it's sharded across all participants. It's resharded with subshards if new participants join or existing one leaves, as long as you still have majority threshold to create the key. And then it allows it to control it that way. And you're just a shard owner. Then by virtue of owning the shard, you can initiate any of these transfers or transactions. But that's not where I want it, actually. Where I want it is on the P2P level. So they're all communicating and sharing that data, and you selectively decide what you consume or what you act upon based on specific codes or signatures or something like that. That's a much better solution, and this is currently just a hack to get it working.
You mentioned snark, by the way. What were the two other things that you mentioned earlier?
So bulletproofs, snarks, and starks are the three primaries in this space.
One more time.
Bulletproofs. And then the other two are very closely related. So snarks, the original adoption was actually by the Zcash team, and a lot of their original designers developed this new protocol, Starks. So it's just from snarks to starks. And they're actually launching Starkware, which is built on the Stark protocol, to be their new privacy coin. So those are the two main ones, snarks and starks. And then the last one is bulletproofs. But if you send me after this your Telegram or something, I did a whole paper on there's 20 different ones of them. So I can share them all with you.
So one more. And mine is actually not really a question, but as with any technology, you can use it for good or evil. I know today's talk is more focused on the technical aspects of it. And with this technology, I think most of us can agree that is to build a better economic system. Maybe some call it near utopia or whatever. Can you guys just, touch a little bit on, what your vision is if this becomes a success, so to speak? What is this utopian world going to be and And if it's not the fail state, what would that be? What would be the consequences?
Look, if I had the choice, I'd definitely use it for evil. I just don't know how to use it for evil. I'm not sure how you would position it to be able to maximize that. I'm going to cycle it around and then let it come back to me, but I'm going to figure out a way how we can use it to be super evil.
Fine. I think that there's the potential in it for a phase, like a epochal shift in our capacity to interact with each other and coordinate. Like right now, like actually, first off, I don't think it's going to be utopian. We've totally destroyed the planet to the point where like we are committed, basically, like biologically, ecologically, like planetarily, to a dystopian world for a while, right? But that in order for us to be able to start doing things differently, just having personal value commitments isn't enough. We need to actually be able to coordinate, and we need newer ways to coordinate, and we need to be able to recognize different flows. So we just need a capacity shift, the way that reading is a capacity shift, or reading and writing are a capacity shift, or like a moving image is a capacity shift. So I see these technologies as having the potential for us to use to interact in ways that allow us to step into what I personally believe is our like role as a species, as like nurturing life on the planet and stewarding it, and instead of just eating it.
I think the problem with our society is that we have a culture that's rooted in a sort of like profit-centric mentality, and that's not sustainable, you know. And I think one of the ways that might help is to talk about, how to create a model that's not focused on profits. Because even today, the crypto community, they're all, entrepreneurs come in and they're like, oh, well, how do we make money from this technology? I guess that's one of my concerns.
So I heard something really interesting in a forum. They were like, at the end of the day, what are these really? They're like distributed databases, right? So the kind of like hard reality is that the reason that why people are so interested in this in the first place is because there are economic incentives. Like, so it's kind of hard to break those two. Like, hopefully, like, I'm not saying that Fantom and IOTA aren't like, very altruistic, but Holochain and like, there are these projects that are trying to say like, we don't really care about the token. We're trying to have like non-token based models. Like, I think they exist, but I think that idea that like, whenever you hear someone on a forum be like, I'm only in it for the tech, it's like, are they really in there for the tech, or are they like there every hour of the day because they're like incentivized to do it? Yeah. So, I mean, I don't know. It's a weird balance, but hopefully.
Okay, I stole it. I'm gonna add something on that. And so to me, just the fact that the technology is here, it's good enough to tell us that it's gonna stay. And of course it's gonna evolve. And if you try to do a sort of an imagination example, and you think about how the world is going to be in 100 years, are we still going to use paper stuff, not only for money, which is already not happening, but what about identity? Are we still going around with our plastic cards or paper cards, showing our data to everyone and stuff like that, and doing crazy line at airports? I really don't see that happening. So we're going, a little bit fast, further in the future. It's not going to happen in a year or two, but I think this is at least the base of. Exactly. Yeah. Yeah. And about the speculation, I think that's actually a really good sign that we got something good here. Same thing happened with the internet. At the beginning was, kind of, it was used, as we all know, the primary uses of the internet in the 90s were porn and evil stuff, and then big boom, big speculation, and that meant something. And then after that, we got to a world that we cannot live without the internet. So I think the same thing is going to happen for blockchain.
Very nicely said. No, well done.
I think that, yeah, I think that you guys really covered it, a lot of it. So yeah, I don't have too much like specific stuffs to add, but it's more about I guess it's just like the empowerment, especially those that don't really have the opportunity. But then if we can have the technology as like a means, or as like a tool for accessibility to give you the opportunity to actually like move forward. And I think it's the ability for these these technologies to actually help people, like is like empowerment and growth for like more people. That's if they choose that path, but it gives them this option.
Awesome. Well, thank you so much for coming, everyone. I want to thank Kevin and Eric and Andre and Simone. They did incredible. Thank you so much for being incredible partners in this. And yeah, we have the next one tentatively for first week of April. I'll let you know. I'm not going to say who it is yet, but I think we have one or two interesting people.
We want to say thank you, Dan, and Protocol NYC for putting this together and bringing us here and hosting this. So thank you for that.
I hope it was valuable. And then I think, again, the most important thing is connecting. I try and put some time together. So we've got about 20 minutes, but before you go, you should connect with each other because we're all really interesting people.